Hello friends, in the last lecture we have seen that the solving of system of linear equations using a method of inversion. Now we shall see the another method, the method of reduction for solving of system of linear equations. From the name of this method, it can be guessed that the given equations are reduced to a certain form to get the solution. Here also we start by converting the given linear equation into the matrix form. Then we perform the matrix form X is equal to B, that is Ax is equal to B. Then we perform the suitable row transformation on the matrix A and reduce it into upper triangular matrix or lower triangular matrix or diagonal matrix. The same row transformation alternatively apply on the matrix B. After this step, we rewrite the equation in the form of system of linear equations, and they are in such a form that they can be one can easily solve by elimination method, and we get the values of the variables x, y, and z. So friends, now we start with the example. First example, solve the equation 2x plus 3y is equal to 9 and y minus x is equal to 2 minus 2 using the method of reduction. Solution: the given matrix form of this given equation, equations is can be written as here it is the matrix form. First one, coefficients of the variable, and then second it is the variable matrix, and last one is the constant matrix, that is the Ax is equal to B. Now we convert the matrix A into upper triangular matrix. For that we use this operation here. R2 is replaced by the elements in R2 changes with the 2R2 plus R1. That means here one can easily check that minus 1 is replaced by 0. That means R2 is replaced by 2R2 plus R1. That means 2 into minus 1 plus 2. That means minus 2 plus 2. 2 into 1 plus 3. That means 2 plus 3. Here it is also minus 2 into 2 minus 4 plus 9. That means 9 minus 4 is equal to 5. That means here this is the upper triangular matrix. Now we multiply this matrices. 2x plus 3y is equal to 9. First equation we get here, and last one is 5y is equal to 5. From using equation 1, y is equal to, using equation second, one can easily check that y is equal to 1, and using y is equal to 1 from equation first, we get here x is equal to 3. It is very simple example. Thus x is equal to 3 and y is equal to 1 are the required values of x and y. Now second example, solve the equations by the method of reduction. X plus 3y plus 3z is equal to 12. X plus 4y plus 4z is equal to 15, and x plus 3y plus 4z is equal to 13. The above equations can be written in matrix form. Ax is equal to B. First one is the coefficient matrix, second one is variable matrix, and third one is constant matrix, where Ax is equal to B. Now we convert this matrix A into identity matrix or upper triangular or lower triangular. We convert this matrix into. For that we use here operation R2 changes into R2 minus 1 and R3 changes into R3 minus 1. That means here both the elements second row first column, and third row first column elements becomes 0. And we get here R, first one R2 changes in R2 minus 1, 1 minus 1 0, 4 minus 3 1, 4 minus 3, and here it is also 1 minus 1, 3 minus 3, 4 minus 3. Same alternatively simultaneously operations 15 minus 12 and 13 minus 12, and we get here the matrix 1 3 3 0 1 0 0 0 1 and 12 3 1. And now again R1 changes into R1 minus 3 R2. That means here both the elements 3 3 becomes here 0. That 1 minus 3 into 0, 3 minus 3 into 1, 3 minus 3 into 1, and same 12 minus 3 into 3. Here it is also R2 changes with R2 minus 3, 0 minus 0, 1 minus 0, 1 minus 0. Here it is 1 minus 1 0. Here is no change, 1 minus 0 1 and 0 minus 0 0. Here only changes in R2 here. Second or third column position 1 minus 1 0. This is the 0. Here it is also 3 minus 1 2. This will convert it. This will be convert this matrix into. Now we multiply both the matrices. We get here x plus y plus 0, 0 plus y plus 0, 0 0, 0 plus 0 plus z is equal to 3 to 1. That means x, y, z is equal to 3 to 1. That means x is equal to 3, y is equal to 2, z is equal to 1, which are the required values of x, y, z. Next example. Solve the following equations by the method of reduction. It is again a 3 by 3 method. First one, the above equations can be written in the form ax is equal to b. In the form. Now we use the operations here. R2 changes with R2 minus R3, and R1 changes with R1 minus 1 by 2 R3. We get here as it is R2 in the row R2 changes with R2 minus R3, 2 minus 1, 3 minus 1, 2 minus 2, and R1 changes with R1 minus 1 by 2 R3, 1 by 2 R3, 1 minus 1 by 2 1, 1 minus 1 by 2 1, 1 minus 1 by 2 into 2. Here it is again simultaneously operation here, and we get here the matrix 1 by 2 1 by 2 0 1 2 0 1 1 2 minus 1 minus 2 4. Again we use the operation R1 changes into R1 minus 1 by 4 R2. We get here in this way 1 by 2 minus 1 by 4 R1, 1 by 2 minus 1 by 4 R2, 0 minus 0. And here it is again 2, minus 1 minus 1 by 4 into minus 2. And this will be convert this matrix into 1 by 4 0 0, 1 2 0, 1 1 2, minus 1 by 2 minus 2 4. Note that here we have reduced the original matrix A to a lower triangular matrix, because the above the diagonal elements are all of the 0. Hence we can rewrite the equations in their original form. That means we multiply these both matrices. That means 1 by 4 into x, 0 into y, 0 into z in this form. And second one, x into 1, 2 into y, 0 into z. And third row and first column, x plus y plus 2z is equal to minus 1 by 2 minus 2 4. And this will changes into 1 by 4 into x, x plus 2y, x plus y plus 2z, minus 1 by 2 minus 2 4. That means we get here three equations. You're now using equation 1, we get here x is equal to minus 2. And now put x is equal to minus 2 in equation second. We get here minus 2 plus 2y is equal to minus 2. That means 2y is equal to minus 2 plus 2 is equal to 0. That means y is equal to 0. Now put x is equal to minus 2, y is equal to 0 in equation third. We get x plus y plus 2z is equal to 4. That means minus 2 plus 0 plus 2z is equal to 4. That means 2z is equal to 4 plus 2. That means 2z is equal to 6. And therefore z is equal to 3. And thus hence x is equal to minus 2, 0, 3 is the Now next example, the cost of 2 books, 6 notebooks is rupees 34, and the cost of 3 books and 4 notebooks is equal to 31. Using the matrices, find the cost of 1 book and 1 notebook. Solution, let us denote rupees x and rupees y with the cost of 1 book and 1 notebook respectively. Hence, using the above information, we get the following equations. That means in here it is the left column regards with the information. The cost of 2 books and 6 notebooks is rupees 34. That means, and we know that cost of 1 book and 1 notebook x and y, and that means equation we get here 2x plus 6y is equal to 34. Similarly, second information, the cost of 3 books and 4 notebooks is rupees 31. That means the equation is 3x plus 4y is equal to 31. Now using the matrices, we will find here the values of x and y. The required equations are 2x plus 6y is equal to 34, 3x plus 4y is equal to 31. The above equations can be expressed in the matrix form as 2, 6, 3, 4, xy, 34, 31. That is therefore x is equal to b. Now using the operation R2 changes with R2 minus 3 by 2 R1, we get here 3 minus 3 by 2, 2, 4 minus 3 by 2 into 6, and 31 minus 3 by 2 into 34. And that means we get here, this will be converting into upper triangular matrix 2, 6, 0 minus 5, 34 minus 20. As the above matrix A is reduced to an upper triangular matrix, we can write the equation in the original form. That means using equation second, y we get here y is equal to 4, and put y is equal to 4 in equation first, we get here x is equal to 5. Therefore the x is equal to 5 there, and we know that the x is the cost of book and 1 book, and y is the cost of 1 notebook. That therefore the cost of a book is rupees 5 and that of a notebook is rupees 4. Hence the required solutions. Thank you.